Hello everyone, myself Professor Dipali Vagude and today I am going to cover the topic Euler's graph.
So the topics I am going to cover are graph, degree of vertex, walk, path, Königsberg 7-wedge problem and Euler graph. So first see some of the definitions that we have to know, that is the preliminaries. So first see this image. What this image shows? This image shows some red lines, some blue dots. Now what are the blue dots? These blue dots are the destinations which we have to travel from one destination to another destinations, and the red line shows the roads joining the destinations. If we want to show this very efficiently, so see this image here, this 1 2 3 4 5, suppose these are the destinations and the lines joining them are the roads. So in terms of graph theory, these destinations are called as vertices. These are called as vertices, and the lines joining the vertices, these are called as edges, and this image is called as graph. So these are the vertices. These are the vertices, and the edges joining them, the lines joining them are called as edges. So what is a graph? We are going to see Euler graph, but first we have to know what is a graph. So graph is a collection of vertices that are the nodes. So these are also called as nodes. These are also called as nodes. And the edges, that the lines, where two vertices are joined by one or more edges, and it is denoted by G of V comma E. Okay. So where V is the vertex set of G and E is the edge set of G. So this is all about graph. Here we can say that the vertices are joined by one or more edges. If we see, so there are two routes, more than two routes that joins the destinations. So we can say that here again there is one edge. So the vertices are joined by one or more edges. The next is degree of a vertex. Degree of the vertex. So what is degree of the vertex? The number of edges incident on a vertex is called as degree of that vertex. The number of edges incident on a vertex is called as degree of that vertex. So suppose if we so consider this vertex 1. Here one is joined to the vertex 2, one is joined to the vertex 3, one is connected to the vertex 4. That means vertex 1 is connected to three vertices, three different vertices, and hence the degree of this vertex is 3, since there are 3 edges incident on the vertex. Here again vertex 2 is connected to vertex 1, 3 and 5. That means there are 3 edges incident on 2. So degree of 2 is 3. Here 5 is connected to 2 vertices, 2 different vertices. So degree of 5 is 2. Suppose this is another vertex 6. This is another vertex 6. Now it is not connected to any of the vertex. So this is the isolated vertex. This is called as isolated vertex. And again suppose there is one vertex 7 which is connected to only vertex 4. So, degree of this vertex is 1 and such vertex is called as pendant vertex. Such vertex is called as pendant vertex and this is isolated vertex and degree of isolated vertex is 0. Degree of isolated vertex is 0. So, the number of edges incident on any vertex is called as degree of the vertex. Next, walk. A finite alternating sequence of vertices and edges beginning and ending with the vertex. A finite alternating sequence of vertices and edges beginning and ending with vertex is called as walk. Now, what is a walk? A finite alternating sequence of vertices and edges. Suppose we want to travel from this vertex. Suppose this is our home. So, suppose this is our home. We want to go to the temple. We want to go to the hospital. We want to go to the school and we want to go to the hotel. This is the hotel. So, we travel from home to temple, we travel from home to temple, temple to hospital, hospital to school, school to hotel again. Or if we want to go to school, so we have direct path, direct access, home to temple we have direct access, home to hospital, we have to travel to temple, temple to hospital, or we can go home to school, school to hospital, or we can travel home to hotel, hotel to school, school to hospital. So, these all are nothing but the walk. These are the walk. So, if we want to write the walk, we can write it as the vertex 1, then the edge, this is 2, this is 5. So, suppose this is the edge E1 and this is the edge A2. So, we can write it as 1 E1 and this is A2. So, if we want to go to this is hospital and this is our home. So, if we want to go to home to hospital, then we will travel the path home to temple, temple to hospital. So, the path is 1, that then E1, then 2 and then E2 and then 5. So, this is our walk. So, this is the finite alternating sequence of vertices and edges. So, we have started from the vertex 1, then traverse to vertex 2 including the edge E1, then we traverse to the vertex 5 including the edge E2. So, this is the walk. The next terminology is path. So, what is a path? A walk in which every vertex is covered without repetition of vertices. A walk in which every vertex is covered without repetition of vertex is called as path. That means, we have to find a walk that does not cover a vertex more than one, and this is called as a path. A walk may consist of repetition of vertices, but a path does not consist of repetition of vertices. So, such type of walk is called as path. Now, these are some basic concepts we need to see what is Euler's graph. So, before going towards Euler graph, we will see a problem, that is the Königsberg-7 bridge problem. Now, what is this problem? In this problem, this is the river, the blue portion shows the river. This is one island, suppose this is A, this is second island, this is the river bank and this is again the river bank. Now, what is the problem? This is the city, this is the river Prigel in the city of Königsberg. So, the city of Königsberg was set on both sides of the Prigel river and included two large islands which were connected each other by 7 bridges. Okay, so A and B, these are the two islands and they are connected by the 7 bridges. That means the river have 7 bridges. Now in the 17th century, people were bothered with the question where they could walk around all 7 bridges, consisting them only once, crossing them only once. So this is the problem of people, that they want to travel each of the bridge without crossing 2 times, or they want to travel each bridge only once. So they have tried many times, but at least one bridge they must have to travel more than one time. So these are some their tries. So if they started from this, then go to this, then go to this, then go to this, go to this, but this bridge has been left. Again here, this is the path. Again this bridge has left. This is the path. One of the bridge have been left by them, and they want to travel each of the bridge only once. So if they have to travel all the or they want to cross all the bridges, then they must have to travel one bridge 2 times. So now one of the famous mathematician Euler, he answered the question as no. And proved that there could be no path or the route in Königsberg that uses all the 7 bridges exactly.